All right, this lesson is about trig applications, and specifically using angles of depression and elevation to help us find lengths of triangles. All right, so first of all, let's just define what an angle of elevation is. Angle of elevation means that you're looking up, and usually it's somebody's looking up from the ground up. Like it's this angle right here. This is your angle theta, moving upwards. Okay, angle of elevation, just like it sounds. So it's a person looking up to the top of a tree or top of a building or something like that. So angle elevation makes sense because it means up. Depression sounds like going down because it is looking down. All right. Now the trick on this is that it's down from the horizontal, which isn't a real line, but it is an imaginary horizontal line with their line of sight. Pretend there's a person in the building looking down, and they talk about the angle of depression from their line of sight. So that's this angle right here. So what does that mean with the triangle that is imagined, like that you really think more towards the ground? Well, what happens is the angle of depression is the same as the opposite angle down here because of alternate interior angles. Back in your geometry days, you learned about parallel lines. Alternate interior angles are always the same. So if you know the angle of depression, up here, then you'll know the angle of elevation in the opposite corner. So keep that in mind as we draw pictures and come up with scenarios for these problems. A homeowner is to construct a ramp to his front door to make it a wheelchair accessible. How long is the ramp if the door is 4 feet above the ground level and the angle of elevation is 20 degrees? All right, so with every problem, sometimes the hardest part is drawing the picture. Well, keep in mind, every one of these is going to be a right triangle. Okay, there it is. Here's my right triangle. All right, now let's start putting some numbers on this. How long is the ramp? Well, this is the ramp length, right? So that's my hypotenuse. That's what I'm looking for. If the door is 4 feet above ground level, so this is 4 feet, and the angle of elevation is 20 degrees. So this is my angle of elevation right here. This is 20 degrees. All right, so now that you have a picture, look at your angle, and relative to your angle, identify the sides you have. 4 feet is opposite that angle. So this is my opposite side, and my x is the hypotenuse. So those are the sides that I need, opposite and hypotenuse. Well, which trig function involves opposite over hypotenuse? Well, that's the sine of theta. So sine is the function I need to use. So the sine of theta, and theta is 20, equals the opposite side, 4 over the hypotenuse. That's my unknown length. Now you have an equation you can solve. I'm just going to put that over 1 and cross multiply. So 4 equals x times the sine of 20. So I divide by the sine of 20. That cancels. And make sure when you put this in your calculator, you don't do 4 divided by 20. It's 4 divided by the sine of 20. Again, making sure your calculator is in degree mode. When I do that, I'm going to get 11.7 feet. All right, 11.7 feet. So, being a word problem, I need to put my answer in a complete sentence, a complete thought. So I would say the ramp will be about 11.7 feet long. Okay, that's all I'm looking for. Not a book, not a paragraph, just a short sentence in a complete thought. All right? Example 2. Number 2, an 80-foot rope is attached to the top of a vertical pole standing in the center of a circus tent. The other end of the rope is attached to a stake 60 feet from the base of the pole. Determine the angle of elevation. So this is different. We're not looking at a side. We're looking at an angle this time. All right, there's a pole in the middle of a circus tent, and there's a rope attached to it that steadies it along with the ground, okay? The rope, it says, is 80 feet long. The other end of the rope is attached to a stake. Here's my stake that it's wrapped around, okay? And it's 60 feet from the base of the pole. Determine the angle of elevation of the rope. So this is my angle of elevation. This is my theta. I don't know theta. So I'm going to show you how to solve for an angle here in a minute. But first, the process is the same. Relative to this angle, what two sides do I have? 60 feet is the adjacent side. 80 feet is the hypotenuse, right? Well, which trig ratio uses adjacent and hypotenuse? That would be cosine. Cosine of theta. All right, so this is the basic formula I'm going to use. So I use the cosine of theta. I have to leave it theta because I don't know what the angle is. Now I'm going to put in what I do know. Adjacent, 60 over 80. All right, so I'm going to type this in my calculator. 60 divided by 80. When I do that, I get 0.75, 3/4. Now, in order to find the angle, you have to use a new button on your calculator. What I need to do is find the inverse of both sides. I need to kind of do the reverse problem here to get the angle. So what you're going to do on your calculator is look for the cosine button, but right above it, it says cosine -1, the inverse. So you have to hit second and cosine, and it's going to pull up this. So when you type in that, you're going to get the inverse cosine of 0.75, and what that's going to give you is the theta, the angle. All right. So if you type that in, it tells you then that theta is 41.4 and it's degrees. Make sure you're in degree mode. Super, super important on all of these problems, guys. Degree mode. All right. So again, word problem complete thought. That's my answer. All that work is my proof. Third question. An observer on the 12th floor of a building determines that the angle of depression of the foot of the building across the street is 54.6 degrees. The angle of elevation of the top of the same building is 82.3 degrees. If the street is 80 feet wide, find the height of the observed building. All right, so we have two buildings here. Here's a 12-story floor building, and there's a taller building up here. All right, and here's the street connecting them. Okay, so there's a dude sticking out his head out the window right here, and this is his line of sight. Remember the imaginary line of sight we talked about? It says, first thing he says is that the angle of depression of the foot to the foot of the building from his line of sight, that angle of depression right here is 54.6 degrees. Now remember we said if it's angle depression, it's the opposite corner's angle of elevation. So 54.6 is this angle right here. Then the next phrase says the angle of elevation to the top of the same building, so he's looking up now to the top, this angle is 82.3 degrees. Then it tells us that the street is 80 feet wide. Find the height of the building. So what we have to do is kind of take this opposite building over here and break it into two parts. This part we're going to call X, this part we're going to call Y. So our final height of the building is whatever X plus Y is. All right, this is more complicated, lots of steps. So let's first take the bottom triangle. All right, let's try to figure out what Y is. So I'm going to draw this out. 80 is the difference in the streets. This angle right here, 54.6. And I need to know this height right here. This is my Y. Actually, I'm going to make it Y. Okay? It's the same length here as it is here. All right, so if I solve this, I'm going to go through the same steps. Relative to this angle, I have the adjacent side, and I'm looking for the opposite side. So which ratio deals with opposite over adjacent? That would be the tangent of theta. So I solve it by saying this. The tangent of theta, which is, theta is 54.6, equals opposite, I don't know, that's my Y, over adjacent, which is 80. All right, I'm going to cross multiply. So Y equals 80 times the tangent, 54.6. And I'm going to find out that Y equals 112.6 feet. Okay, there's Y. I know this portion of the height of the building. Now I need to find the top. So if I draw that, if I draw this triangle, this is my X, this is 82.3, and I know that this is still 80 feet apart. But I'm looking for that X. Now look at this. Relative to this angle, this is the opposite and this is the adjacent. So thankfully it's still tangent of theta that I'm using, opposite over adjacent. So put my theta in there. So it's the tangent of 82.3 equals, opposite is my X over adjacent, which is 80. Cross multiply, X is going to equal 80 times the tangent of 82.3. Type that in my calculator, and I'm going to find out that it's 591.7 feet. All right, so my final answer is what's the height of the whole building? So I have to take 112.6 add 591.7, and that will give me my solution, 704. Lots of steps, all very doable. Last example. A surveyor observes that the top of a building makes an angle of 32 or 37.2 degrees with the road. All right. From another location 400 feet away, the angle of elevation is 20 degrees. How far apart is the base of the building from the first observation point? Okay, picture's always the hardest part. So let's just think, here's the ground, and here's the point 1, observation point 1. And there's a building here, okay? Some strange building. And observation point 1 is looking at the top. That is 37.2 degrees angle of elevation. From another point that's 400 feet away, so this is 400 feet away, it says this angle of elevation is only 20 degrees. How far is the base of the building? So this is what I need to find over here. How far is that first observation point, this distance right here? In order to find that, I have to know how tall this building is. I don't know enough with just this part right over here on the left. I need to know the height of the building before I can solve this. So I'm going to solve over here on the right first. Looking at the sides I have relative to my angle 20, I have adjacent and I have opposite. So remember that tangent of theta is always the opposite over the adjacent. So I'm going to solve for x. So my tangent of 20 degrees is my opposite side, I don't know what that is, over the adjacent. So in order to find the height of the building, I do x equals 400 times the tangent of 20. And that's going to tell me then that I'm going to get 145.6 feet. That's the height of the building. Now I can work with this triangle to find how far this distance is. Okay, I'm going to call it y just to keep it simple. This is my angle, 37.2, and now I know the height is 145.6. So part 2 of this, I have to solve for this side. Okay, again, opposite over adjacent, right? So it's still tangent. So it's tangent of 37.2 equals opposite over adjacent. That's the unknown. All right. If I cross multiply, you get y times the tangent of 37.2 equals 145.6. In order to get y by itself, I have to divide then by the tangent of 37.2. I've got to do that to both sides. Now be careful, don't put in your calculator 145.6 divided by 32. It's the tangent of 32, so make sure that's in parentheses. When you do that, you're going to find out that the building, or I'm sorry, that first observation site is about 191.8 feet away. All right, so again, complete thought. I would say the building is approximately 191.8 feet from observation 1. Okay? All right, I hope that makes sense. Lots of steps. Take it methodically, get your picture, figure out which trig ratio, plug in your values. All right, this one, not a big deal. Go back to example 3 and tell me how far apart were the buildings. Okay, and we'll do these in class tomorrow.